Hello, everybody. Mr. Rubo here. So we're going to go ahead and do pages 1, 2, and 3 in our chapter 3 notes. Um, so the first question here is given that we have AB equals 5, BC equals 8, and AC equals 6, and then XZ equals 5, YZ equals 8, and XY equals 6. And we're asking, are the two triangles congruent? Or I guess I should reword that. Is triangle ABC congruent to triangle ZXY? So if you, and then also why and why not? Why or why not? And the reason, the answer is no. So if you look through this and kind of match them up and everything, the biggest thing is that when we name congruent triangles, they have to be they have to correspond um, with their congruent sides. So in other words, where in the first, the first two letters are AB in the first triangle, ZX in the second. So we have to know AB is congruent to ZX, which it is. But then if you look at BC and XY, because those are the second and third letters, BC is 8, XY is 6. So that means it is not congruent in the way that it's written. So the reason corresponding sides do not match up. So order matters when you are naming triangles congruent. So if you were to, like, you do have congruent triangles here, but it would be triangles ABC is congruent to triangle XZY. Okay. So be careful when dealing with congruent triangles, and that's what this whole chapter is on. So that's why we start off there, because that is a very common mistake, is people just miss putting letters in the wrong order based on the congruency. All right, so then the next number 2 here is just a proof. So we are given QS is congruent to RT, PR is congruent to PS, and angle 1 is congruent to angle 2. Okay. So, and we are trying to prove that triangle PRQ is congruent to PST. So, um, with that, we're looking at these two outside triangles, and we want to see if they have sides that are the same, angles that are the same, and eventually say that the triangles are the same. So we're going to start off with the QS is congruent to RT, which there you can see it's the overlapping. So QS and RT overlap, which is the big thing that we can say now those outside segments are congruent, QR and ST, because segment subtraction, right? If segments subtracted from congruent segments, then their differences are congruent. So if you subtract RS from both QS and RT, you get QR is congruent to TS. All right. And then we're going to throw in the next two pieces of given information. So PR is congruent to PS. So right now, so far, we have proven or been told that, doesn't want to, right, hold on. We've been told, my smart board's going crazy. Whatever, it's not working. So yeah, we've been told that we have those two angles congruent, that side congruent, and then QR is congruent to ST. All right, and so now, based on that, we do know that angle PRQ, which is an angle inside of our triangle, or one of our triangles, I should say, is supplementary to angle 2, and if two angles form a straight angle, then they are supplementary. And then similarly, angle PST is supplementary to angle 1, and that is, again, if two angles form a straight angle, they are supplementary. And so we can then say that those two angles are congruent, PRQ and angle PST, because if two angles are supplementary to congruent angles, then they are congruent themselves. And last, we can now get our statement that we were trying to prove, which is triangle PRQ is congruent to triangle PST by side angle side. And I even put the steps where I said each of the sides and the angles, right? So step 2, there was one of our sides. Step 3 was the other side. PR is congruent to PS. And then 7 was the two congruent angles. It's really helpful if you put, like, if you choose side angle side, or if you prove it using side angle side, or side side side, or whichever triangle congruency you choose or you end up using, I would highly recommend putting which steps you said those congruencies in, because if you can't say what steps, then you did not prove it, right? So you have to be able to say, like, oh, okay, I did prove congruent sides in 2 and 3, and then I proved the angle in between on step 7. All right, looking at number 3, this one is not a proof, but a just a more algebraic one. They want us to find JK, so side JK, which is the hypotenuse over here. We do know the two triangles are congruent, and we also know that side MO is double MN. Okay, so because of that, we can set up a few equations here. So the first one I'm going to do is say x plus 10 equals 8y plus 4x plus 13, which is literally saying NO is congruent to KL. And if you look at the lettering, ON or NO were the first two letters, which means they correspond to KL. So that's why I chose those two. Even though, like, these triangles are orientated in a different manner, if you use the triangle congruency statement, you know what to set equal to each other. All right, so that's for this one. I was able to solve it. And then for this one, I say x minus 2y equals 2x plus y plus 2. You might ask, where did the x minus 2y come in? Well, that was me taking MO and dividing it by 2, because that gives me MN. And then MN I can set congruent to 2x plus 2, or plus y plus 2, because that is JL. And then it's a system, so we do our usual system stuff. I decided to use elimination here and multiply this one by 3. So then I add straight down. X's cancel. You get y equals negative 3. Substitute it back in to get x equals 7. And then they wanted to find JK, which JK was congruent to MO. So I just substitute the x and the y in, and that's how I get the 26. Let me hide this real quick. So that is how I get the 26. Okay. So yeah, that's just, again, using that triangle congruency statement. All right, moving on to page 2. We have another proof on this page. And for this proof, we are told BC is congruent to DE. Angle BCD, which is this outside angle here, is congruent to EDC, this other outside angle. Outside of the triangle is what I mean by there. And then AD is congruent to CF. So this proof is almost identical to the one we just did on the last page. So you'll see a very similar steps, similar reasons. The only thing is, instead of naming one of the angles angle 1 and 2, they didn't. And so here we go. So we're going to start with our given. And actually, we're going to start with two pieces of given. So right away, we know BC is congruent to DE, which means we have a side, right? We have a corresponding sides that are congruent. So now we have these angles that are on the outside. And just like the last time, we're going to state the supplements, right? So angle ACB is supplement to angle BCD. And then same reason, angle FDE is supplement to angle EDC. Again, it's because they form a straight angle, so they are supplementary. And then we can say, they're congruent to each other because two angles that are supplementary to congruent angles, they are then congruent themselves. So as of right now, what I've proven so far, or what I was given, is that we have this corresponding sides, and then we have a corresponding angle. So now the last thing we need to prove is either is another side congruent, and specifically AC and DF, because we can then say side angle side again. And so again, we have this overlapping given information of congruent segments. So we're going to use that, right? AD is congruent to CF. And again, if we subtract, if a segment is subtracted from congruent segments, then the differences are congruent. And there's AC is congruent to FD, which is exactly what we wanted. To finish off our proof, we now can state triangle ABC is congruent to triangle FED by side angle side. So you can kind of see those both proofs were very, very similar. Honestly, it was just the order in terms of the order that I decided to do it in. The first one I dealt with the subtraction first, and then I did the straight angles. This one I ended up doing the straight angles first, and then dealt with the subtraction. So you kind of see either way would work. And again, side angle side, and I listed out what steps I showed those congruencies. Okay, so step one of the given steps was where the side was congruent. 5 was where I got the angle, and then 7 was where I got the other side. All right. So now, if we look at page 3, this kind of will help us with our 3 triangle congruency reasons. So the 3 are side, 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 side angle, and angle, side, angle. Those will prove that 2 triangles are congruent. So really, I've got the answers here, but we can kind of just see it as we kind of go. So here we have those corresponding angles congruent. Corresponding segments congruent. Then the corresponding angles are vertical angles, and then corresponding sides on the bottom. So it is side angle side for that one. Okay. D, if you look, we do have corresponding sides congruent, and then a corresponding angle congruent. However, it's not side, 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 side angle, or angle, side, angle, because the order of it does matter. So these 2 sides are congruent, but the angle is not between them, right? So the angle has to be between the 2 congruent sides for us to use side angle side. If it's not, then it's none. And then if we look at C here they're just telling us about the angles. So they're telling us all 3 angles are congruent. Well, that's great, but technically I can draw, think about equilateral triangles. I can draw 2 equilateral triangles that have different sizes, like side lengths, but they all have the same angles. So that would mean they are definitely not congruent if you just know about the angles, right? All right, and then if we look at D, there's a lot of information going on here, but we know that angle B and angle E are congruent, right? And then we know C, like the angles on the ACD and ADC are congruent, which means their supplements are congruent. And then, and just like we did on the proof, because we have this overlapping, if we subtract CD from both of them, we would then have angle, side, angle. Okay. So yes, this one we have to do a little bit of work, but we can do it and prove that that these 2 outside triangles are indeed congruent. Okay. And there's actually other ways of proving that one as well, but angle, side, angle is probably the quickest. All right, here in 3, 4, and oops, I guess 3, 4, 6, 7. I guess we skipped number 5. We're just kind of given information and kind of deciding which method or which of the congruency statements we're gonna use. So AB is congruent to BC. We have a side. We have the angles here. And then the last side is BD is congruent to BD, right? If you ever have that shared side, by the reflexive property, we know BD is congruent to BD, which means we have side angle side. Okay, so that's that one. Here, angle 1 is congruent to angle 2. EF is congruent to FH or HF. Those are given, and they don't give us anything else. But how do we prove it? Well, we have vertical angles, right? So vertical angles are congruent, which means we have angle side angle. All right, and then with number 6, we're told about bisecting angles here. So if you are bisecting angles, you will know that that's congruent to that, and then this one is congruent. Sorry guys, I'm trying to do this with my mouse because it was not working earlier with my stylus. So we have those angles are congruent, those angles are congruent, and then just like 2 above, we have a shared side, which means SV is congruent to SV. So we do have angle side angle. So whenever you have those angles that are shared, okay. And then the last one, TV is congruent to XW. VA is congruent to WA. And then TA is congruent to XA, all given information, and that is all 3 sides given, which right away we don't have to do any extra work. We know that those 2 triangles are congruent by side, side, side. All right, so thank you for watching and have a good day.